Here we are looking at solving quadratics by factoring. So a key part we have to use here is what we call the zero product property. And that tells us if we multiply two values together and get a product of zero, which is zero product property, then that gives us that either a equals 0 or b equals 0 if a and b are the product. Now we change that to be binomials, which we've been looking at with quadratics. So if I have x minus a times x minus b equals 0, in order for multiplication to work, one of these things has to be 0. So we would say then that x minus a equals 0 or x minus b equals 0. Where this really comes into use is if I have actual binomials. So let's say x plus 3 times x plus 2. So that means x plus 3 equals 0 or x plus 2 equals 0. I can solve both of these and get x equals negative 3 by subtracting 3 from both sides, and then x equals negative 2 by subtracting 2 from both sides. This gives us the solutions we want of this binomial, of the two binomials. What we can do is then take a step back and we can then factor to get to this point and then find solutions. So steps we're going to look for. We want to make sure all terms are on the same side. A few of them that we see may not be the case. We want to factor the quadratics completely. We want to set each factor equal to 0, like we did here. And then we're going to solve for each of the factors' equations to get our solutions. So let's move down to some basic ones. So this here is already factored, but I'm going to set each of its factors equal to 0. So negative 3n equals 0. If I divide both sides by negative 3, I get n equals 0 over negative 3, or 0. On the other one, 2n minus 5, if I add 5 to both sides, I get 2n equals 5. Divide by 2, I get 5 over 2. So that gives me 0 or 5 over 2 as my solutions. And what that means is these are the only two numbers that if we substitute in would give us a true statement of 0 equals 0. That's what we're looking for, solutions. So here is a little more familiar quadratic we've had. So we have to factor it first. I'm looking at what multiplies to negative 14 that adds to negative 5. Now we'll do factor by grouping. If you know the shortcut for the factoring, you can do that, but we'll at least work through the factor by grouping, assuming we're remembering this from before. So multiplies to negative 14 that adds to negative 5. I'm going to do 7 and 2 will give me 14. We're going to make the 7 negative. So m squared minus 7m plus 2m minus 14 equals 0. We factor the first two, take an m out, we're left with m minus 7. Factor 2 out, we're left with m minus 7. Now, they both have m minus 7 in common, so we factor that out, and we're left with m plus 2 equals 0. From here, we use our zero product property, and we say that m minus 7 equals 0 and m plus 2 equals 0, which gives us m equals 7 and m equals negative 2. Our next one, p squared plus p minus 20. We're going to look to multiply to negative 20. That adds to 1. 5 and 4 are good candidates. Let's go with a negative 4, positive 5. So p squared plus 5p minus 4p minus 20. First two I can take out a p, and I have p plus 5. The last two I can take out a negative 4, and I'm left with p plus 5. P plus 5 is the common term. We factor that out, and we're left with p minus 4. We now set both of those factors equal to 0. P plus 5 equals 0 gives us p equals negative 5. And p minus 4 equals 0 gives us p equals 4. So our solutions are negative 5 or positive 4. And our next problem, x squared plus 14x equals negative 49. We're not going to factor the left side because we have this number over here. And it's not called the negative 49 product property. It's the zero product property. So we need 0 on the right side. So I'm going to subtract, or I should say add, the negative 49 over. So now it's x squared plus 14x plus 49. What multiplies to 49 that adds to 14? Well, that's 7 and 7. So we're going to go x squared plus 7x plus 7x plus 49. equals 0. We factor an x out of the first two. We can factor a 7 out of the other two, which give us our same terms of x plus 7. Comes out, and we're left with x plus 7. Now, they are the same thing, so I don't have to do both of them with zero product property. I could just say x plus 7 equals 0, so x equals negative 7. It has one solution, and that's the one we want. So now we have g squared plus 4g minus 32. So negative 32, and we want 4. I'm thinking 8 and negative 4 would be the values. So g squared plus 8g minus 4g minus 32. I could take a g out of the first two, which leaves me with g plus 8. A negative 4 out of the next two, which leaves me with g plus 8. So g plus 8 is the common term. G minus 4 is left over. So now we go g plus 8 equals 0 and g minus 4 equals 0, giving us solutions of negative 8 or positive 4. Now we kind of make the factoring a little bit more advanced here. We now have that lead term. So it's 3 and negative 14 is negative 42. Negative 42, that adds to 1. So we're looking at maybe 6 and 7 sound good. If I make it a negative 6, then it adds to positive 1. So this is where we split the q to be negative 6q and 7q. Factor the first two terms, I can take out a 3q, and that leaves me with q minus 2. The next two I can factor out a 7, and that leaves me with q minus 2. Q minus 2 is the common term. 3q plus 7 is left. So now I have q minus 2 equals 0, and 3q plus 7 equals 0. Q minus 2 just becomes q equals 2. 3q plus 7, subtract 7. So we got 3q equals negative 7. Then divide by 3, it's negative 7/3. So our two answers are 2 or negative 7/3. Next problem, multiply 2 and 18, that gives me 36, and I want it to be negative 15. Well, if they're both negative, that's two values, it gets me a positive, I'm going to try, how about negative 12 and negative 3? Those add to negative 15, but they also multiply to be a positive 36. So this one's maybe a little tougher one to find, but let's do those two values. So 2a squared minus 12a minus 3a plus 18 equals 0. We can take a 2a out of our first two terms, leaves us with a minus 6. We can take out a 3a, or 3, negative 3 from the next two, leaves me with a minus 6. So in common they have a minus 6, 2a minus 3 is left. So we'll say a minus 6 equals 0 and 2a minus 3 equals 0. One solution for a minus 6 is a equals 6. On the other side we have 2a equals 3 and a equals 3 over 2. So our solutions are 6 or 3 over 2. Next we have c squared equals 5c. We can't divide both sides by c. It doesn't work that way. What we need to do is get it all to one side. And that's what we've really done on all the other ones so far. So now it's c squared minus 5c. Not a trinomial, but they have in common a c. So when that comes out, we're left with c times c minus 5, which set the factors equal to 0. C equals 0, that one's done. Add 5, we get c equals 5, so c is 0 or 5. Down in our bottom left one here, I have that negative 10 on the other side. I need to move them over so they are all on the same side. We multiply first and last terms and get 30, and that adds to 17. So multiplies to 30, adds to 17. I think 15 and 2 are the two numbers I would like. 3h squared plus 15h plus 2h plus 10. We're going to take out a 3h from our first two terms, and it leaves me with h plus 5. We take out a 2 from the last two terms, it leaves us with h plus 5. H plus 5 is the common term. Leaves you with 3h plus 2. So we set h plus 5 equal to 0 and 3h plus 2 equal to 0. H is negative 5 from the left one. The right side, we're going to go 3h equals negative 2, and h is negative 2/3. So negative 5 or negative 2/3. Last, x squared minus 4x minus 5. Multiply to negative 5, that adds to negative 4. I'm thinking negative 5, positive 1. So x squared minus 5x plus x minus 5. We're going to factor an x out of the first two. Leaves us with x minus 5. Can't factor anything out of the next two, so we're just going to write the 1 on the outside. They both have x minus 5. That factors out. X plus 1 is left, so we'd say x minus 5 equals 0, and x plus 1 equals 0. This gives us x equals 5, or x equals negative 1.